Let's have a look at question 14. A balloon has been inflated. In a simple model, the balloon is modeled as a sphere. The rate of increase of radius of the balloon is inversely proportional to the square root of the radius of the balloon. And then at time t seconds, the radius of the balloon is r centimeter. So write down a differential equation to model the situation. So basically, the rate of increase of the radius, that's just dr over dt. And then because it's an increase, it's positive. And it's inversely proportional to the square root of the radius. So if it's inversely proportional, it has to be some constant divided by the square root of the radius, which is just square root of r. So that would be the answer for part A. Very simple. Mark. And then for part B, we just have to solve this. So because you can't integrate r with respect to t, so you have to move all the r to one side and then move all the rest to the other side. So I will times by root r for both sides. And then I will times by dt for both sides. And then integrate it one by one. So root r is r to the power half. To integrate this, just plus 1 the power, so it becomes 3 over 2, and divide by the power. And then kt plus c. So then r to the power 3 over 2 is equal to 3 over 2 kt plus 3 over 2 c. And then we need to use the condition to work out each number k and c. So it says at the instant when t equal to 10, the radius is 16, and then the radius is increasing at a rate of 0.3 centimeter per second. So substitute in, so when t equal to 10, radius is 16, so we can substitute that first. So then 16 to the power 3 over 2 equal to 3 over 2k times by t, which is 10, plus 3 over 2c. So then 16 to the power of 3 over 2, that's just 64. So 64 equal to 3 over 2 times by 10, and that would be 15. So 15k plus 3 over 2c. And then we need another equation to solve k or c to set up the simultaneous equation to solve it. And then the second information they gave us is the radius is increasing at the rate of 0.3 centimeter per second. So if it's the rate of change of the radius, so we can just use the original one, this. So it says when t equal to 10, radius is 16. So, and then the rate of increasing of radius is 0.9. So we can just let dr over dt to be 0.9. And then radius is 16. So just 0.9 equal to k over root 16. So then k has to be 0.9 times by root 16, which is 4. So that would be 3.6. So now we know what k is, substitute in. So 64 equal to 15 times by 3.6 plus 3 over 2c. So then 64 minus 15 times 3.6, which is 10, equal to 3 over 2c. So c has to be times 2 for both sides and divide by 3, 20 over 3. So therefore, our final answer would be r to the power 3 over 2 equal to 3 over 2 times by k, which we already know is equal to 3.6, and then t plus 3 over 2 times by c, which is 20 over 3. So then r to the power 3 over 2 equal to, so 3 over 2 times by 3.6 is equal to 5.4. And then 3 over 2 times by 20 over 3, that would be 10. And that's exactly what they ask us to show. So another 5 marks. And then part C. Hence, find the radius of the balloon when t equal to 20, and then give your answer to the nearest millimeter. So be careful with the units here. So the units for the radius of the balloon is centimeter, but this time they want us to give the answer to the nearest millimeter. So always be careful with the units in the modeling question. All right, so t equal to 20, substitute in, so that would be r to the power 3 over 2 equal to 5.4 times by t, which is 20 plus 10. So then R the part 3/2 is just equal to, so 5.4 times 20 plus 10 is equal to 118. So then R has to be equal to 118 the part 2/3. Because if you only cancel out the power, you just do the power of the reciprocal. Because 3/2 times 2/3 become 1. That's how we cancel out the power. So 118 the power of 2/3, which is equal to 24.0577. But they want us to give the answer to the nearest millimeter. So 4 is to the nearest centimeter. So 1 centimeter is equal to 10 millimeter. So like this has to be to the nearest millimeter. So then R has to be 24.1 centimeter. Okay, and then part D is suggest an imitation of the model. So because this is a balloon, it can't like keep increasing forever, right? So eventually, at some point, it will burst. So you just say balloon can, the balloon cannot be inflated forever. It may be burst. Let's have a look at question 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water, so the water starts to leak from a small hole at a point L in the side of the tank. So, which is point L here. Okay. While the tank is leaking, the depths h meters of the water in the tank is modeled by the differential equation dH/dt equal to negative 0.12 e to the power negative 0.12 t. So where t hours is the time after the leak starts. So be careful with all the units. So t is in hours and then h is in meters. And then using the model, A show that h equal to A e to the power negative 0.2 t plus B, where A, B are constants to be found. Okay, so for part A, we just have to integrate dH/dt equal to negative 0.12 e to the power negative 0.2 t. So for this one, we don't have to use separation of variable because the expression on the right-hand side is just in terms of t. So there's no h in it. So we don't need to do separation of variable. We just have to integrate straight away. So h is just the integral of negative 0.12 e to the power negative 0.2 t dt. So that means h is equal to negative 0.12 is the coefficients, they're the same. And then since this is just a linear expression, so just e to the power negative 0.2 t, and then divide by the coefficient of t, which is negative 0.2 plus c. So simplify that, h equal to negative over negative cancelled, and then 0.12 divided by 0.2 is equal to 3/5. So h equal to 3/5 e to the power negative 0.2 t plus c. And now we need to find out the value of C. It says initially the tank is full of water. So that means when T equal to 0, so the cylindrical tank of a height 1.5 meters. So if it's full of water, that means the height of the water should be 1.5 meters. So H equal to 1.5. So then substitute in h equal to 1.5 and then t equal to 0. So that would be 1.5 equal to 3/5. And then e to the power 0 is just 1 plus c. So c is just equal to 1.5 minus 3/5, which is equal to 0.9. So then h equal to 3/5, which is 0.6. Let me just change it all into decimal. So 0.6 e to the power negative 0.2 t, and then plus c, which is 0.9. Then that'll be the final answer for part A. It's only 3 marks. Okay, part B. Find the time taken for the depth of water to decrease to 1.2 meter. Give your answer in hours and minutes to the nearest minute. So for part B, we want to work out time when which is t. So when the height become 1.2 meter, so we just let h equal to 1.2. So 1.2 equal to 0.6 e to the power negative 0.2 t plus 0.9. So minus 0.9 for both sides, that would be 0.3 equal to 0.6 e to the power negative 0.2 t. And then divide by 0.6. So 0.3 divided by 0.6 is just equal to 1/2. So 1/2 equal to e to the power negative 0.2 t. So that means negative 0.2 t is just equal to ln of 1/2. So, and then 0.2 t should be the same as ln 2 because ln 1/2 is negative of ln 2. And then, so t is just equal to, so 5 ln 2. So because divided by 0.2, 1 over 0.2 is equal to 5. So 5 times by ln 2, put in the calculator, we have t is equal to 3.46573, and then the units would be hours. But be careful about what they're asking you. So give you answer in hours and minutes to the nearest minute. So then that should be 3 hours. And then we need to change 0.46573 hours into minutes. So it comes by 60 for 0.46573. So that'll be 27.94. And they want to the nearest minute. So 27.94 is just 28 minutes. So then that will be the final answer for part B. So that's another 3 marks. And then part C, in the long term, the water level in the tank falls to the same height as the hole. So part C, find according to the model, the height of the hole from the bottom of the tank. So basically, it's just asking you what's the limiting height. So if we let t goes into infinity, so that means e to the power of negative 0.2 t will go to 0. Because e to the power of negative 0.2 t will goes something like this, a diagram. So as t get bigger, it'll get smaller and smaller, eventually turns to 0. So which means h should turns into 0.6 times 0 just 0. So just plus 0.9 is just 0.9. So that means the height of the hole from the bottom of the tank should be 0.9 meters.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.